So we're going to look at the IDE, which is called Android Studio. Fortunately, it is based on IntelliJ, so hopefully you'll be familiar with quite a lot of it. We'll have a look at the structure of a project in Android Studio. We'll look at building a UI. We'll look at making sure our applications can be turned quite easily into another language. And we'll look at how we can run applications using an emulator, because obviously we don't want to have a separate device, especially if we haven't got an Android device, in order to test our applications. And then we're just going to look at one thing that might come up, particularly if you're looking for resources on the web as you're learning Java in your own personal development time, something that you need to be aware of. And then we'll do a demo, although we'll probably do a bit of demo as we go through it anyway. So, as I said, we'll use Android Studio. It's kind of like IntelliJ IDEA in many ways. It uses something called a Gradle build tool, okay? And this kind of sits in our project as like some Gradle configuration files. And when we create our application, when we put our code and everything together, we have to, certain things have got to happen to turn that code into an Android application. Okay, so like images have to be packaged up. The Java has to, or Kotlin code has to be compiled, application has to be signed, okay? We might be using libraries to give us some sort of backwards compatibility, or using a resource like a library that someone else has provided for networking or something like that. And Gradle allows us to specify, for example, those packages that we want to include. Some of it will already be set up for us, and it just kind of gets on and does it. Okay. You'll notice, you'll get messages like Gradle build happening when we change certain things, but you don't have to worry about it too much. Just be aware that it's there, and I think there's a bit about it in the course book if you want to read some more. But we will see it a bit here and there throughout the course. Okay. So this is a screenshot of a structure of a simple Android application. When you're running Android Studio, this sort of layout appears on the left-hand side by default. And it's kind of split into, at least within our app part of it, 3 sections. So you'll see we've got this app bit, and then we've got this Gradle scripts bit. And within app, we've got manifests, Java, and res. Okay. So the manifest is like where the project structure is explained or set out. Okay. So the various bits of our application are sort of specified in there. Okay, so it will say what the initial screen, which is known as an activity, is, and we use it to set things like permissions. So, for example, if our application needs to access the internet because we're making some sort of call to an API, we need to specify that permission is required. If we want to send text on behalf of the user, we need to specify that permission is required as well. So, those of you who've got Android phones, I think when you install an Android app, it comes up and says this application will do X, Y, and Z, yeah? They're those permissions, okay? Bit different to iOS, where you tend to get prompted at the point the application wants to use them, whereas you kind of have to agree to them when you install an app in Android. So then we've got this Java folder, and you're like, we've been doing Kotlin for the last 2 weeks. Why is there a Java folder? So our Kotlin code goes in a Java folder, just to because that's the Android way of doing things. Is not necessarily the most helpful way, but yes, our code in Kotlin goes inside a folder that's labeled Java. And you can see in this particular example, we've got a Kotlin file called main activity. So that would be mainactivity.kt. And an activity is like the equivalent of a screen, one sort of view on an Android phone or Android application. And then we've got this res folder, and there's sort of subfolders in res. Res is for resources. So we've got things like layout, so that defines how those activities appear on screen. So that's a bit like your HTML if you're doing a web app, but it's XML rather than HTML. And then we've got other resources, so we might have raw resources like audio and video files. We will also use an XML file for our strings. So if we might have some text in our application, like, I don't know, the word that says menu or something, we store that rather than just hard coding it into the application. in a strings.xml file, and that makes it really easy if we want to get our application translated into another language, because we can quite easily like add a different variant for that string. So we give it like a name, then we give it like the English that we'd use, like the word menu, and then we can add additional translations for that. So that's kind of the basic layout. I think before we move on, we'll quickly like start up and create a new Android application in Android Studio. So you'll find that Android Studio can be launched from the icon that looks like that. So it's a green circle with like a protractor, or is it a protractor? I think it's a protractor. When you fire it up, you'll get this screen here, unless you've got a project already open. And I'm going to choose this Start a New Android Studio Project. Just a word of advice: if you're working on the network, you'll get all sorts of problems. So you'll have to create your programs on the local machine when you work with them, and then copy them across to your network drive once you're done for the day. Okay, so I'm going to create an application. I'm going to call it Hello World. I'm going to call it Hello World 2 because we've already done Hello World earlier today. Specify the domain. We don't put it in reverse format because it automatically does that. You can see that where it says package name com.tinyappco here. So it will take the application and the company, reverse the company domain, and append the name of the application without the spaces to the package. And then what's really important is, because we can do this in Kotlin, we check the include Kotlin support checkbox. If we don't do that, we'll only be able to write Java code, which isn't going to do us much fun because Java is like more painful to work with in Android than Kotlin. So we'll say next. Okay. The next thing is that we have to determine what we want to support in terms of versions of Android. Okay. How many people here have got an iOS device? Okay, for 5. Okay. How many of you have updated to iOS 12? A fair number of you. And how many of you are able to update to iOS 12 if you haven't already and would want to? Anyone stuck on a previous version of iOS? No, everyone could or is updated. So most people have updated. Okay, how many people here got an Android phone? Okay, how many of you are running the latest version of the Android operating system? And of those of you who aren't, how many of you are able to upgrade to the latest version of the Android operating system? Yeah, not so much. Because of the way that the Android is distributed, the phone manufacturers add their own layers on top of the software. So if Google release an update, whether the update makes it to your device. Of those of you who are on the latest version, of those of you who have been able to upgrade, how many of you have got an Android device, as in like a Google device? No? So what devices have you got that you've been able to upgrade? Anyone? So, for example, if you buy like a Sony Android device, have you been able to upgrade to the latest version of the Android operating system? You have? Okay, cool. That is not always the case, as I'm sure you're aware. Might be with Sony, but might not be with... There's an update like every 2 weeks. Okay, oh, that's pretty good. Okay. But not every phone manufacturer will offer every update that Google release. So you're running Android Pie, yeah? On your... Yeah, okay, cool. So we kind of might want to work out how far back we want to go to target our application. So we can choose from the drop-down, you know, do we want to target everything from ice cream sandwich onwards? And if we do that, we get about everybody. But, you know, if we want to run the latest version of Android, which is Android Pie, API 28, if we pick that, less than 1%, yes.
Why are they named?
Why are they named after desserts?
Yes.
That's what they decided. I have no idea the reasoning behind that, but they have decided to name them after desserts. They are alphabetical, which kind of helps with working out which one we should be on. If we go back as far as Oreo, then 6% of Android devices are running Oreo. Okay, I think if we look at the number of people that have adopted iOS 12, which came out a month ago, it's about 50% of people who've got devices are running the latest version, whereas Oreo came out, what, like a year ago? And we got 6% of Android users on Oreo or later. So that's Oreo or Pie combined. If we go to Nougat, only 37%. Marshmallow, 62%. Okay, so we're going to leave it at ice cream sandwich because we want apps to run for everyone. We can target other platforms for Android, like Android Wear, although I get the impression not many people have Android Wear watches, and they're mostly other platforms. Android Auto, I think that's probably a bit more popular if you've got a, you know, CarPlay or whatever unit it is. or even like Android things. So we're just going to do phone and tablet. Okay. We then choose whether we want like an initial screen rather than having to do it all by scratch. I think we do. So we'll start with an empty activity, which is like almost empty, but not quite empty. The suggestion for naming is a bit weird. So main activity makes sense. This will be our Kotlin class name. But the layout uses the format where we have the type of whatever it is, in this case activity, underscore and then main. If we'd called this hello world activity, this layout would be activity underscore hello underscore world. Okay, so you kind of have to get used to the XML file not having the same name as the activity file or it being flipped around. So yeah, so we're going to leave it as backwards compatible, and we're going to generate this layout file. If we take that off, we don't get our layout. And although we can create a layout programmatically from scratch, it's an awful lot more work. So, you know, we're programmers. We don't want to do extra work that we don't need to do, so let's not do that. I'll hit finish. So at this point, you might find your computer sort of sits there for however long, probably a lot longer than this does, and kind of goes away and gets set up. Okay. So we've now got our application. We have got our app folder that I talked about, our Gradle scripts, and within app we've got our manifest. So here's our Android manifest.xml file. And if we have a look in that, we can see we've got this XML, this application attribute, and inside that we've got an activity. Okay, we could have more than one activity, but we've only got one at the moment. And it's got a name, and then we've got some called intent filters that kind of specify that what happens when we launch our application, where does it go? We want it to go into this particular activity. If we add a new activity using like the menu system within Android, we'll automatically get like this added into our manifest. If we do it manually, like we create a Kotlin file and then we specify that it's a subclass of activity, this won't happen, and then our application won't be able to find it. So it's kind of important that it makes it easier if we add our activity by like right-clicking and going like new activity and then like basic activity or empty activity or what have you, because that will add it into the manifest. Okay. As I said already, we put like things like what sort of security aspects we need. Do we need access to the internet? Do we have access to the user's location? Do we need to send text messages? That kind of thing. So, and then we've got our Java folder with our Kotlin file in it. We get like 3 versions here, but in the top one we've got like tests. We've got this main activity. Okay, and that's what we had open already. That's our Kotlin class. It extends app compat activity, which is like a backwards compatible version of the activity class. And it's already got some code in it, which we'll come to in a little bit. And then we've got our resources folder. And inside resources, if we expand that, we've got our layout folder, and this is activity main.xml file. And we can either view that as like a design or as a text preview. But again, I'll come back to that in a minute. So, so the Android UI is based around this idea of activities. So each activity is like a screen. One activity can start off another activity, and we can go and go to the different screens. And typically they're represented in XML. And as I've shown you already, we can see the XML and we can see the editor. Unfortunately, it's quite often that we actually need to modify the XML. It's not just drag and drop, although we can get a fair bit done with drag and drop. And then we've got that corresponding activity class. And as I talked about the naming convention, it's a bit weird. We'd name the Kotlin file like whatever activity typically, and then the XML is named like activity underscore, and then the various bits of the name of the activity we've given it in the Kotlin's name for the activity. There's a bit of a life cycle to activities. We'll talk more about that next week. But basically, one thing we do need to know is that it has an onCreate method. And in onCreate, the activity like hooks up the XML. So the fact that the names are like similar doesn't by itself make it work. The onCreate method has a method called setContentView. And that points to the layout file and gets it all set up. So if we have a look at our back to our code here for our main activity, here's that onCreate, and here's this line, setContentView. And you'll notice we've got this like, what's this r.layout. activity main. So in Java, we've got this like R, or in Kotlin, whatever, static class, where we can go and find things that are in our layout. We can find our strings. So it's basically R stands for like resources, and it lets us get stuff out of or reference stuff in the resources folder. Okay. So when we create something in resources, we get a corresponding like property in our R class. So we've got r.layout.activity_main. That obviously corresponds to activity_main.xml inside our layout folder with R for resources. It has to be a capital R. Obviously, if we take this out, if we're like refactoring and move it somewhere else, if we don't have this line of code, we're not going to get our layout at all, and then we're going to have a problem. So we need to remember that's what's going on there. That's how the two are hooked up. Okay, I talked about earlier about strings. We don't typically want to hard code these into our application. Okay, if we write, like say we've got a label and we hard code the text for that label in, or text, it's not called a label, is it? It's called a text view. Then it makes it harder to internationalize it. So instead we have like an XML file full of strings, and we can create versions of the XML file for different languages, so that our application can work in other languages. So that's known as I18N. Does anyone know why it's called I18N? I was amazed. I didn't think anyone would know it, but someone in the first class did. It's to do with the number of letters between I and N in internationalization. So it's like a shorthand way of writing internationalization. So instead of using like a string literal, we do r.string, and then dot, and then whatever name we give that string reference. We'll see this in a minute when we run through a bit of a demo. Okay. If we're in the XML, we like do @string / and then whatever we've named our string. Okay. So sometimes we'll specify the string in the XML, sometimes we'll specify it in code, and there's a couple of different ways of doing it. Yeah, let's actually do that, and then we'll come back to the slides. So here's my Hello World application. Let's say I want just to have, let's go to my layout, okay, and here is my, now at the moment it's just got like a text view in it, it's kind of tiny, so I'll try and make that a little bit larger so you can see what's going on. I'm going to just delete it and put my own one in, and I'll show you a little bit about the editor while we do it. Okay, so by default, this little thing here, which is called autoconnect, is switched off. So there's a line through it. So you'll probably find if you load it up, there'll be a line through this. We've got this palette. These are different things we can add to our application. Okay, so text view lets me display some text. So I'm going to drag my text view on here. Okay, and it will let me drop it pretty much anywhere. Okay, and then we get this like attributes view here. So we can show what's displayed in the text. So I might make this say like hello world, and that's updated and is showing it there. Okay. Now the other thing that we'll find is that we need to specify how things are laid out. Okay. So if we look in the text representation of our XML, we'll see we've got this thing called a constraint layout. There are different ways of laying things out in Android Studio. One of the newest and most powerful ways of doing it is this thing called a constraint layout. Okay. Now,
Where do you find the text representation?
the little tab at the bottom here. So you should see two little tabs. So you at this end, down here you've got design and text. Okay. So here's our text view. Okay, but it's giving us this warning, like the view is not constrained, it only has design time positions and will jump to 0, 0. Okay, so we have to use this type of layout called a constraint layout. We can see that text view is inside a constraint layout. We have to set constraints so it knows where to go. Okay, now we can do that manually, but it's a bit of a pain. So what we'll do instead is we'll go to the designer, and I'm going to turn on autoconnect, right? Now, I don't know whether I'll be able to get away with just dragging it and hoping it will connect it, or whether I'll have to, yes, okay. And can you see it's put these like wiggly lines? So these are constraints, okay? So it's saying that it's going to be like constrained to the left and the right of the screen, to the parent, we'd call it. Okay, we can constrain things to other objects as well. Now it's constrained left and right, but it's not constrained to the top, so we've probably still got a warning. Here we go, missing constraints. It's not constrained vertically. Okay, so we need to like constrain it to the top here. Now we can either like drag it up and hope it kind of makes a constraint. Yeah, can you see that that's added like here? It's got a solid line now, it's like put in a constraint. But we can also drag the little dots around to put constraints in as well. If I go back to my text at this point, it's added all these constraint things in, okay? So we've got this text view is the layout is constrained, the end of the layout is constrained to the end of the parent, so that's like the right-hand side. The start, i.e. the left-hand side, is constrained to the start of the parent, and the top is constrained to the parent. And then we've got this kind of bias thing. I don't think we're using that, so we could actually get rid of that. It's probably because of the way I dragged it around as to... you can have things, if you've got multiple things like sat next to each other, you can give them a bias as to how much they'll take up of the screen. So if we go back to activity, oh, sorry, to the design of our activity. There we go, that's sat there. And we can adjust, the padding, and we've got other properties. So like somewhere down here, there's like a font or text size, and maybe you want to make it a bit bigger. So I set to 24. You'll notice it's got these like SP, that's like for, I think it's scaling pixels. We use that for fonts, and then if we're specifying like other dimensions, like you'll see we've got this margin at the top. It's very easy to look at it here. We've got this DP, and they're like device independent pixels. So you might have some Android phones that are low resolution and some that are really high resolution. And this kind of provides a standard sort of set of measurements that we can work with that are independent of the resolution of the screen that we're working on. Okay, so we're getting there. Okay, but we've got this like warning where it says hello world. We've got this string that's going to display, and it's saying we should use a string resource instead. Okay, and if we were in a design view, we'd get like a warning here. If it's not on, we can click the little triangle, and it comes up hard-coded text. Should use a string resource, and it gives us reasons why it's bad. So, like we can't translate it to another language just by adding new translations for string resources, and it gave me a different reason earlier. But anyway, you have to repeat actual text. Yeah, so if you, maybe it didn't give me a different reason. If you've got two different versions of the same layout, like one for landscape, you might have to put that same string in again. And then if you change it, you've got to change it in two places. And we don't like repetition and redundancy as, we might like repetition, but we don't like redundancy as programmers. So we might as well say that it's a string resource. So we can do that. We can either click this little fix button here, or if we're in the text view, you can like use a little light bulb when it pops up eventually. Give me the light bulb. Come on, give me a light bulb. There we go. And you can choose extract string resource. If you don't get the light bulb, you can press, I think it's Command and Enter. No, Alt and Enter, Alt and Enter, or Option and Enter on the Mac. I think it's like one of those buttons at the bottom left on Windows. And we choose extract string resource. And then it will offer to create us a resource. It will suggest a name based on the text, and it will give us the value of the text. And then we can just click OK. And that warning's gone away, and now it's got this references like @string/hello world. And it should be green. I don't know if you can quite see. No, you can't really see it's green. Sometimes it lights up green. So we haven't got that warning anymore, so we should have lost all our warnings. We've got no warnings anymore, which is good to see. No warnings. Okay, so if we wanted to translate that, we could go and modify some strings, which we will do in a little bit. They pop up in values, and then you've got this strings.xml file, and there's our string. So hello world, and there's our string. We create different versions for different languages. Let's just say we'll get to in a minute. Okay. Right, testing applications. So as I said already, you don't have to have an Android device to test. You can if you want. If you've got an Android device, you can plug it in and install a bit of software and get it running. But we can emulate it. Okay. This will work on most laptops. I think you might have problems with some processors, maybe like AMD ones. And if you get an error about virtualization, you might have to enable virtualization in your BIOS if you do find you get to that problem on your own machines. It can be a bit slow, even on the Macs, which are new, can be a bit slow to boot, so it's generally a good idea just to keep it open. Okay. when we come to run our application the first time, you'll find that it will prompt you to create or use an existing emulator, and there might not be an emulator set up. Okay, so I've got my application there. It says hello world. If I come to hit run, it will pop up with this box. It will show any connected devices, and then it will show any available virtual ones. If there are none, you'll have to click this create new virtual device. Okay, and then we can pick a device to use, and it will give us like an emulated version of that device. So the one I would suggest you definitely add is a Nexus 5X, because when you come to the assignment, it does need to work at least on that device. Now, ideally, you'll build it in such a way it works on all sorts of Android devices, but that's the one to go. Okay, and then when you do that and click next, it will prompt you to determine what version of the API, so what version of Android you want to install. Please make sure you have one with API 28. You may need to download these. They're rather large. And we can add multiple different versions of versions of the operating system to put on as well. You just have to click download and then you can install it. Okay, so you do that, you get a little bit more configuration. You can give it a name, and then it will set that up for you. So I've already got one, so I'll just click cancel. If you're searching for things in Java, actually finding like elements like a text view to change programmatically is a bit of a pain. Okay, so I'll show you how we do it. It's a lot easier in Kotlin, fortunately. So let's say actually I want to programmatically change where it says hello world to say something else instead. Okay, so if we're in Java, I'm going to write Kotlin code, but we'd have to write equivalent Java. I would do something like let text view. Now this text view will have an ID, not let, sorry, wrong language, that's Swift. Val text view. We might just want to check what we've called it. So it is called text view. Okay, we'll leave it like that for now. Val text view. In fact, let's not use the same name. Let's call it TV hello. We'd say something like val text view equals find view by ID. Then if it was Java, we'd have to cast it, but in Kotlin we can say is a text view. We'll have to import this. When I hit enter, it's going to add an import statement. So like just to prove it, when I hit enter, there we go, it's added it in. And then we have to say like r.id. And then whatever we named it, which I think was TV hello. So that like finds it, and then we can say like text view dot, and then we can set the text. Okay, so text equals hello CO5225. Okay. Fortunately, we don't have to do this in Kotlin. Okay, we get these nice sort of extensions in Kotlin, which it just adds an import statement when we start to try and refer to it, which basically goes away and like says, oh, what are all the things in this particular resource, in activity underscore main in this case, and like goes ahead and creates like properties that we can use. Okay, so we don't have to do this find view by ID. So if you're searching and you find source code in Java and you come to convert it, most of the time, if it's got this find view by ID, you don't need to worry about that. You can just reference it by name. So I can get rid of all this whole r.id.tv hello. All right, I can literally just write tv hello.text. Okay, and as soon as I hit enter, just watch the imports. It adds that import here. Okay, we don't need the straight reference to text view anymore. So that's a bit simpler in Kotlin. Well, it's a lot simpler. Okay. I have, however, got a warning where it says hello CO5225. Anyone like to take a guess as to why I've got a warning there? It's in yellow. Okay, I'll hover over and we can have a look. It's because I can't translate it, because we haven't put it into a string resource, so we've got no way of like referencing it for translation. So it wants us to turn it into a string resource. Okay. Again, we can use it with a light bulb, or we can use like whatever it was, Command and Enter or Alt and Enter. And there's this extract string resource button. So let's do that. What is it called? Hello CO425. So I can say hello underscore CO5225, and then click OK. And then it changes it to call this getString method that passes in r.string.hello CO5225. And now, if we look at my strings, I've got the string. Okay. Now, that's all well and good, but you kind of think, well, this is an awful lot of effort. Okay. So what we could do is we could actually add some translation and see the difference. So at the moment, if I run it, okay, we should see that the text says hello CO5225 because we've replaced it programmatically. So let's just test that. Okay, it does. Okay, but let's go set up a translation and fix it so we can see it in another language. So I'm going to go to my strings and I'm going to click on this Open Editor button. And here we go. We've got the option to pick another language and add it to our. I think we've got our default values. We've got our names. We can specify that some things might be untranslatable. So the name of our app, right? If we've called our app, I don't know, something like Uber, we don't really want to have to translate Uber into all different languages because it might not work. Or I don't know, like Tinder. Does that have a French? It's probably called Tinder in France. So we can click untranslatable for that. But we probably are interested in translating hello world and hello CO5225. So we can click this little box here. Does anybody, I asked in the last class, does anyone speak another language and can type those two things in another language? Yeah, do you want to do it? What language? Norwegian. Okay, so we will add Norwegian from the list, which has got every language. And Norwegian in Norway or one of the other varieties? This one? Yeah. In Norway? Yeah. Okay, so we can add that in, and what it will do, it will ask us for the Norwegian translation. Yeah. So do you need a Norwegian keyboard to type it? No. No, oh, that's handy. So if you just type hello world in the translation there, so it should already be, oh yeah, you can type it directly in there, I think. And then if you could do hello, is it just hello 5225 for that one?
It's the same.
Okay, so yeah, CO525. Cool, thanks. So if we run our app as it is, it's going to show us the English one probably, because I think that's the second language set up on the device. We had Greek in the first one. I needed a different keyboard, which was rather complicated. But okay, but if we open the settings for the device, come on, oh, I have to go up here. I'm not used to Android. I'm on iOS. I'm an iOS man. And in System, and we go to languages and languages, we can, oh, it's got rid of my Greek one. So we can add language, okay, and we can scroll through this list, which scrolls really badly on the phone, and we should find Norwegian. It's gone, I've gone past it now. That's Norwegian, yeah? And then this top option, yeah? Okay, so then I can drag that to be the primary language for the device, and what we should see is the device changes to Norwegian. Okay, so I don't think I'm not sure whether my app would have changed immediately. We can flick back to it and find out. Yeah, there we go. We can see it's now displaying in Norwegian. So it's reasonably easy to add translations to our application, provided we use the resource strings. Okay. Right, shall we, done resources? Yeah, let's keep going. And I'll do a big demo at the end. So, sometimes we're going to have to make use of interfaces in a minute, so we'll just have a quick recap on how they work. So, if you remember from last year, an interface defines how something should be. So, typically, we give an interface a name, and then we declare the stub or what's it called, the signature of the method that we want it to be implemented. Now, it doesn't necessarily, it won't include normally how the method is, how it is implemented, because that could vary, but we say how it should be. Okay, so I think the example we gave last year was with a plug. Okay, we can't store state in an interface. Okay, just to confuse things and for full transparency, with Kotlin, if we have an interface, we can actually write an implementation for a method in an interface, which is a bit weird, but we're not going to do that today. But we just need to remember that an interface defines how something should be. Okay. Now we're going to use this because we want to be able to handle clicks. So although Android is for a touch screen, The way it is like designed is it thinks that when you touch it, it's a click. I have no idea why. It seems really stupid. So if we want to have a button that handles a click or handles a touch, we have to implement an on-click listener. So basically, a button can be told that a click listener will respond to when a user taps it. But click listener has to take a particular format. So the interface is called onClick listener, and the interface has one method called onClick, and it takes a parameter of a view. Okay, so anything that wants to handle the click for a button has got to implement onClick. So if we've got an activity, and the activity has a button in it, and we want that activity to handle when the button is pressed, the activity has got to implement the onClick listener and have that onClick method. Okay, so what we'll do, we'll go ahead and get a button, and we'll make it so that when the user clicks the button, instead of it saying hello 5225 automatically, it will say hello world to start with. When they click the button, it will change it to hello 5225. Okay, so we'll go to our activity. Okay, I'm going to drag a button on. Okay, again, I've got the auto connect on. I'm going to drop it here. Okay, and I haven't got a constraint here, so I can click and drag it up there. Okay, did it connect? I think it connected. We can have a look at the buttons. Connection. Let's go to the top. How do I get the normal view back? View attributes. There we go. Yeah, it's got a connection. And we could have checked that in a thing. Here's our button, and we can see the button. The left and the right, the start and the end, are connected to the parent, but the top of the button is connected to the bottom of my text view. Okay, and we've got a margin of 8 pixels. Okay, I've got 16 pixels here, so again, I'm going to get some consistency and go for 16 there. Okay. I probably should change the string for the button, but we've done one already, and or at least create a string resource. I won't do the translation though. So let's make the text say press me, and then we'll add a string resource, extract string resource, and we'll just say OK. We'll put it in the Norwegian one, but we won't have a translation for that at the moment. OK, so I want something to happen when I press that button. So if I run it at the moment, the button should appear. Might be blank because I haven't added a translation for Norwegian, or it might just use the English, I'm not sure. Yeah, there we go. Nothing happens when I press it. It's kind of useless. So what I can do is I can go to my activity, and I can, what's going on there? I can say when it loads that I want that button, which I need to know what it's called. So I have to go back to my main activity and check. It's called button. That's nice and easy. Let's call it, I don't know, btn greet. Go back to my activity, and then we'd say something like btn greet dot set on click listener. Okay, and it wants a listener to be passed into there. Okay, well, I want them for now. I want that activity to be the listener, so I can just say like this. Okay, but it's going to complain because it's going to say actually the on-click listener needs to be something that implements the view.onClickListener interface. But actually, you've given me an activity, in particular main activity. And main activity doesn't implement view.onClickListener. Okay, so it's a bit like me punching a hole in this trunking here and saying it's a plug. You might come along and say it's not a plug. There's no socket. Or it's not a socket. There's no holes to put the plug into. Okay, so I can say that that's what the listener is, but it isn't a listener. It's a lie. So I actually have to make the main activity class adopt the interface. So in Java, we'd write implements view.onClickListener. Kotlin's a bit more succinct, so we can just do a comma and say view.onClickListener. It needs me to import view, so let's just do that with hitting enter when we type it, and do onClickListener. Okay. So now we've said that main activity is an onClickListener, but now it's complaining here because it's saying, okay, I've said that the main activity is a onClickListener, but it's not. It hasn't got the method that you need, the onClick method. So it's not really an onClick listener. You're lying again. Okay, so we can fix that. We can use the light bulb, or we can do alt-click. We can choose implement members. OnClick listener only has one method, so it's only prompting us to implement one method. So I'm going to implement it. And then it's going to add onClick method. And it gives me this to-do code, which I'm just going to get rid of. Okay, so now what happens is the button knows that the activity is listening for the click, and the activity is saying, okay, when there's a click, I'm going to do something. So what I'm going to do, I'm going to take this code here and move it up here so that when it starts, it just says hello world. And then when we click the button, it says hello 5225. So let's try it out. So there we go, still in Norwegian. And there we go, we get the change. Okay. Is there what, sorry?
Because the change between a hello world to hello
5225, yep.
It doesn't change between the two different types, change to another string.
It switched to the other, yes. So the hello world one is, if we go to our strings, this hello world string here, which is referenced in activity as string hello world. Yep. When we click the button, we go to strings to get the hello CO5225, and that's, why does it keep doing that? There we go, r.string.hello CO5225. This is just a way to reference it in code, and the, where are we going with activity? We do @string/hello world in our XML. Is that okay? Yeah? Okay. Admittedly, we should add a translation for that, because currently we haven't got, for our press.me, if I close the translations editor and open it again, we really should add a translation here. It does go a bit funny sometimes, the translations editor. I don't know quite why that is. The translations are there, but now they're not showing properly. Okay, so that's one way of doing it. This does, however, potentially lead on to a problem. What happens if I've got an extra button and I want the other button to do something different? Okay, it's all well and good. I could get my other button and say set onClick listener this, but the problem is it's always going to call this onClick method. Okay, so that's kind of annoying. Now, there is a way round if we do that. So let's say we had another button, we don't. What we could do is like check what view this is and check, because that view is the button that's got the onClick handler. So we could say something like if v, which is the parameter we've called view, we could rename it view if we wanted to, and we could check its ID, and then we could say is it equal to, and then we could compare it to the ID of the button that we're looking for. Now we can't just unfortunately compare it to, we know the button is called, could I call it BTN greet? So I can't, unfortunately, oops, I can't just do this, because v.id is actually an integer. So we have to do like that whole r.id and then BTN greet. So we can do that, and then we say, okay, if they match, then we do this. There's still one more problem here though, and that is that view is a nullable view. So we have to do like a safe call on it and check that if it exists, then what's the ID, and if it does exist, does it match? But this is a bit horrible, because then we have to do that for every button that we add. So there's got to be a better way, right? So there kind of is, but we're going to get there a bit of a messy way. So I'm going to start off, and rather than setting the activity to be onClick listener, I'm going to get rid of that. I'm going to get rid of this. And I'm going to create an onClick listener here as like an anonymous object. So if you remember from last year when we looked at adding event handlers to our Swing buttons in Swing, we did something like this. We select object, and it implements view.onClickListener, or it'd just be some sort of other click listener before, and then we declare an anonymous inline object, and then that has to implement the onClick method. So we have to override the onClick method, and then in there we can write our code. So let's just copy that. So that should work. Okay, let's try it out, check it still does. You might think that's even worse. It's kind of almost a bit more messy, because we're creating this object on the fly and then shoving it in to the onClick listener as the onClick listener property. But it does still work. Okay, so yeah, kind of. If we were doing Java, this is pretty much, obviously it would be Java code, but we pretty much have to do the same thing. But fortunately for us, Kotlin has got some optimizations. And one of the optimizations for Kotlin is that if the parameter for a method like setOnClickListener is an object that implements an interface, and the interface only has one method, So view.onClickListener only has one method, which is onClick. We can abstract away like all of this. Okay, so what we can do instead, and it will let us do it. If we see, it says convert to lambda. Okay, so if we use a light bulb, it literally, boom, like actually gets rid of all that. So behind the scenes, it is like creating the onClick listener and implementing the onClick method for it, and this code is going in the onClick method, but it actually like abstracts that all away from us. So where we have horrible syntax for setting onClick listeners in Java, we get nice syntax, or not quite so bad syntax in Kotlin. Okay. What's even kind of more crazy is that the onClick listener has a parameter, a view. Yeah, we remembered if we go back to what we had before. There we go. The parameter view passed into the method. Okay. Now, if I redo what I had, which is what Control-Shift-Z, you can see this little helper pops up here. So this is not actually no code. It's just saying like view is called it. So whereas before, if I needed to access the view, maybe I wanted to like hide it once I click the button or something, I can still get to it by using the keyword it. So I can add more code in here, and I can say like it, which is the button, or whatever's passed into that method. And then last time to prove it worked, and I'll do it again, we can set the alpha value to like 0.2. So it should become, and it's a float, it should become like almost invisible or much more transparent once we've clicked the button. Okay, so this is the view. And it says automatically declared based on the expected type. So it's kind of clever like that. So let's just prove that still works. So this time we should get the same message, but the button should then like be much more faded after we pressed it. There we go. So that works. So that saves us a bit of pain that we wouldn't otherwise have to worry about, or would have pain if we were working in Java. So that's what we had. We had this interface on onClick listener. Then we could like create an anonymous object. In this case, I did it slightly different. I actually created a listener, and then I passed the listener into the button. But we could pass all of that, like everything from object down to the closing brace instead of listener. But that's what we did the second time. But then we optimized it. We used the optimization to avoid having to have all that extra code. Okay. I'm going to start afresh and build pretty much that application, but with an edit text so we can collect some data from the user as well. And I'm going to do something I actually missed in the first class, which is unfortunate, which will show you another way of handling a button press. Okay, so let's start from scratch. So I'm going to close it all down and run back from the beginning. We're going to do new Android Studio project. I'll say hello world 3. Again, we've got Kotlin support enabled. Again, we're going to target like the lowest common denominator or the lowest version of Android that's going to allow the most number of devices to run it. We'll start with an empty activity. We'll call it main activity. We'll generate the layout file. And I'm not going to do translations, but I am going to create the string resources for it. So I'll start off. We get a text view by default. I'm going to delete it. We can delete it in the UI designer, or we can remove it from the XML. Make sure we delete the whole text view and don't leave any like closing braces or anything like that. So let's get rid of that. And what I'm interested in is I want like an edit text. So text view is for looking at text. All these other options with the lines underneath are edit texts that are designed to collect different types of data. So if you, for example, choose the email one, it'll probably give you a keyboard that's like formatted specifically for typing email addresses. I just want the user's name, so I'm going to drag in a plain text one. I'm going to pop it there. Okay. And it's even given me an input type, so it knows it's after a name, even though I use plain text. We can change that to like all sorts of other different random things, but actually a person's name is what I want, so I'll leave that as it is. It's got some text. I don't want any text in it, so I'm going to delete that. Okay, but I would like a hint. So if I look at the warnings at the moment, it's telling me that there's one that's missing constraints, so we can infer constraints. That gets rid of that one. But it's missing an accessibility label because there's no text in it. How do people know what to type? So if I add a hint and say your name, okay, then that warning goes away eventually. Come on, go away. We've still got this hard-coded text warning, so I can fix that. by clicking the fix button and then clicking OK. So that would change that to a string resource, at string your name. And then I want a button under that. So I'm going to drag in a button. On infer constraints again. Make the button text say, press me. Again, we'll have to fix this in a second. Okay, again, we've got this hard-coded resource, so we can click fix. We'll turn it into a string resource. And then I want a text view under that. I'm going to make it a bit bigger because that's tiny. So we can view all attributes, and we can scroll down to text size, and let's make it like 18 at least. And again, we'll infer constraints. And then we maybe like tidy it up and give the same margin for each one. 16 device independent pixels, 16 there, and 16 here. And I don't want any text in that text view by default, so I'm just going to delete that. And you can see all the constraints are set up. So like the edit text is at the top and it's just constrained to the top of the parent. The button is constrained to the top of the edit text and widthways to the parent, and the text view is constrained to the top of the button. That's the bottom of the button, sorry, and widthways to the parent. So there's our kind of layout. So I showed you how to add a button programmatically. If we're working in an activity, we can actually add like an on-click handler for a button here. Okay, so we can actually like specify a method that the on-click calls. So if I start typing on, it will suggest things where on are in the title and on-click is there. And if I do that, it will give me like the prefix. And then I can give a name of a method. So like, what should I call it? I'll say button pressed. Okay. Now it will warn me that that button is not found in the view. Now, unfortunately, because we're working in Kotlin, if I try and use the create button pressed view in main activity, all it will do is say like IDE error occurred, and we don't get anywhere. So we have to create this method ourselves. So I'm going to have to go in here. I'm going to create a method. I'm going to say fun button press. It's got to match exactly, and it's got to take a parameter that is a view. We can call it what we like, but so v or view, but it can be anything else. We'll add an import for view, and then we can write code to like handle button. That warning will have gone away now because I've matched that method. So that's one way of doing it. Okay. Well, what do I want to happen at this point? I want to say hello, and I want to get the text from the edit text, which is called edit text. So I might just like go with the consistency and say like edit text name, and then button greet and text view greeting. Now, obviously, if I've renamed these, it's mucked up here, so I can say that's going to be the edit text name, and then this is going to be screwed up. This is going to be button greet. Okay, so just be careful if we rename things. So what do I want to happen? I want to say that the text view greeting. So notice that's added the import and I hit enter, and I want to set its text to be hello plus. Now we could do it as a string, so we could do like hello, and then we want to get their name. Well, we haven't got the name yet, so we could say val name equals, and that's an edit text name dot text. Now we need to be careful here, because if we look at the text property of this edit text, it's not actually a string. It's an editable, whatever an editable is. I've no idea. Presumably something editable. So we might have to like get that, and then like call to string on it to convert it to a string. Okay, so then we can say hello name. Okay, now it will warn us we've got a couple of problems here. One is that hello isn't in our list of resources, and also it's complaining that because sometimes if we inject a word into a sentence, depending on the language, the word could go in a different location. And it's like, well, you might say in some languages name and then the word for hello. Okay, we're not going to fix it now because we tried to fix it. I tried to fix it in the first class, and even though I followed the instructions on the Android website, it just like ignored me and told me that it didn't work. So what we will do is we'll change hello into a string and fix that bit of the problem. So I'm just going to quickly do that and extract string resource and just say hello, and then we can do say plus, and then we can do a space plus name. Okay. So it's still a bit annoyed that you're not using resource string with placeholder, but you know you can try following the instructions for that on the Android website, and it doesn't work. So we won't worry about that for now. So what should happen is we should get the code to run when we hit the button. Let's just try it out. You see we've got this Gradle build going on down here. So I can click in here, type my name, hit the button, and there we go. We get the greeting. Okay. We've got a button text from init view. We specified a method name in XML. As I say, it's not always appropriate. So we have done this already, so I'm not going to go back through it all. But if we wanted just to do the kind of quick way, we could just say button greet dot set on click listener, and then we could say whatever the function is here. So let's extract that. So we could say fun or private fun greet. The other downside to having it in the XML is that this method has to be public, or at least internal, whereas I can make this greeting private if I move that to here. So let's take that out, put that in there, and then I can just say greet. And then we can get rid of that. We can get rid of this. We can run our code again and we'll get the exact same result unless I've cocked up. There we go. That's all working. Okay. I realise I have been through an awful lot there. What questions do people want to ask? Yeah.
You know, on kind of like the aspects of designing the application, is it down to personal preference, or is it better to hard code it or graphically design it?
So in terms of the layout,
Yeah.
yeah, it's down to preference. Chances are, because getting things to sort of work well can be a bit fiddly in the designer. Like if you've got a lot of items on the screen, unless you've got a particularly large screen, connecting up some of the constraints is a bit difficult. So you do find yourself jumping into the XML to try and fix things. My kind of approach has been, you never used to get the editor. So a lot of the tutorials will all be like, just do this in XML and don't worry about the editor. But my approach has kind of been like, try and get it about as right as I can in the designer, and then like tweak it in the XML to try and get it to work as I need it to, where I can't quite do it by hand. Yeah, so I don't think there's any real rule as to what you do, but I think that's probably the likely workflow.